Welcome to an IronCAD demonstration focusing on the technical aspects of the 2D sketch positioning. This demonstration may not be new to existing channel partners, but could be used as a refresher, but it is helpful for new channel partners getting an understanding of the IronCAD's basics in sketch and positioning curves once they're created. Let's first start off by creating a 2D sketch, and we'll just use our hotkeys to create a sketch in our environment. And we're quickly going to just conceptually draw out some geometry. And as we draw our geometry, you'll see feedback begin to appear. Notice we're getting horizontal information when we're drawing our line, and when we create our next line, notice we get blue feedback indicators telling us perpendicular and horizontal lines, as well as the green feedback, which is called Smart Snap feedback. You can see that they're giving us parallel lines as well. Notice when we draw this line, it's giving us parallel to the geometry. And you can turn this geometry off. If you just hold your Shift key, that information goes away if you don't necessarily want to snap horizontal or parallel. But if you do want to maintain that information, just turn off your Shift key and that information will apply to give you nice feedback to quickly sketch out your concept. Once geometry is created, this is where IronCAD has some unique capabilities to help users position their sketch relative either to the sketch coordinate system or to the curves itself inside of the sketch element. Now, the one nice thing about IronCAD's capabilities, it doesn't matter if the geometry was imported or created by the user. All this information is already obtained in the sketch, and you can leverage it at any time. For example, we have different display types up here. For example, we have a curve, dimensions, and a position, endpoint position information. Let's start off with the endpoint position information to give you an idea of what this means. Basically, on any element that you select, you can get information on where the curve is related with regards to the XY coordinates by default. For example, maybe we want to move this bottom line to be right at the zero element or zero placement point on the sketch. We just select the dimension and double click it and type in the value, and our curve will automatically change to that. If we want to set the height on the other curve, we can do the same thing, just basically selecting the other line. It's giving the information for us to drive it vertically. Maybe we want to set that 1.5, we can drive that element. Notice that I'm not selecting on the vertical line to drive its height, because this is not a curve dimension, this is a position, so it's positioning the endpoints. So you want to actually pick on the curve that you want to move horizontal or vertical. For example, if you wanted to pick this curve element, this will drive it left or right. If I wanted to move it up and down, this curve will be used to move it up and down. The other nice capability with the endpoint dimensions is it can be used on a group of curves. For example, we maybe want to move all these elements that we have selected here. We can box select those, select one of the elements. We get a display for the position information. We can simply double click that and say maybe we want to set that to 9. We can move all those elements out a certain set distance, which is very handy in positioning your sketch. Let's move over to the curve dimensions, and I'll come back to position dimensions in one more second. But let's go to curve dimensions to show some of the capabilities of the curve dimensions. Exactly what it sounds like. Basically, when you select on any curve, you can get various information about the curve, its length and its angle. For example, we know we set this 1.5. We also want to set this 1.5, but we already set our distance here. Notice our arrow is pointing to our right. Well, we don't want to move our outside dimension. We want to move the other side. It's a simple operation. Notice if you select on either side of the curve, just think if there's an imaginary midpoint. You pick on the opposite side of the curve, the arrow will change to give you a different direction of that curve when you edit it. This information is also displayed in your property browser. Notice it's giving us the same value, the angle here, and it's also updating based on the curve information. The difference is, even if you don't have this on, this is still in play. Notice if I select here, it's giving me a positive 90. Select here, it's a negative 90. It's doing the same curve operations. Notice the angle changes more apparent here. You can see that the same curve dimension operations are changing inside the property browser. You just don't visually understand which element's moving. So with the display on, you can actually see it much better of which end is going to move when you're picking on the opposite sides of the midpoints. But let's get back to our top here. We're going to make that 1.5 and moving it to the left. We can actually change that very simple by typing in the value. Another nice thing about these curve dimensions, what they have is, notice these little blue handles that appear. These handles work on both angles and on the actual length elements. For example, maybe we want to move this element down to be at the same location as our other line. Well, we don't know that distance, but we can simply grab this point, and notice once we move over this curve, it automatically snaps right to that element. No, I don't have to hold any keys down. It automatically just snaps to those elements for you without having to set any value, so you can get a really precise location of your curves. This also works for angles. Notice when I select on this angle, I can drag this point and it will give me the ability to adjust its angle. And notice if you move slowly, it will actually snap to small 1-degree increments. But when there's no smart snap appearing, you can see the 1-degree increments. When a smart snap appears, it's going to try to give you alignment to that. This is where it's handy to hold the shift key down to turn off those elements so you can actually get an exact value. For example, we wanted 45. I'd hold the shift key down, get to the 45, and release my mouse. The other nice thing with these handles is you can actually use them to align to other curve elements. For example, in this case, how you know which end of the curve is going to move when I drag this point, it's going to tell you based on the length arrow. If I move this point, this is the end that's going to move. For example, we can see that top element moves. If I switch the curve to the other side, when I drag this element, that end of the curve will be the one that's adjusting inside of there. Okay, so it's really handy to be able to understand which one's moving. And again, we can move these down. If you hold the shift key down when you're dragging an angle handle and move your cursor over another aligned or an angled line, it will actually snap automatically to that, and you can see the 135 or negative 45, if you will, automatically snap and align to that geometry. Now, as you can see, at this point, we have this set distance to be 1.5 and our top distance to be 1.5. But how do we set the distance between these two lines? Notice we don't have a real easy way to do that. Well, let's go back to our position dimensions real quick. And you can see our position dimensions are by default, like I stated before, are aligned to your XY coordinate system. However, you can redefine this information. For example, we want to adjust that this line is going to move, and we want it to be a set distance from here, or we want this line to move, we want it to be a set distance from here. We can select on either line to move, grab one of the indicators, doesn't matter which one, and you can notice when you grab it, you get a little handle icon, and you can snap to any other line. It's basically redefining what it's relating to. So now we can just adjust that distance to be 1.5, since we want this end of the element to move, not our one that we already set. And now we have our constant thickness of 1.5 throughout the geometries inside of there. Now it's a key thing to note, if you don't change this back, it'll always maintain that. So when you pick on other lines, notice they're trying to maintain this weird angle association between our y, and now this is our x, if you will. So it's always nice when you're done with that, always to set it back to the x, y, z, so when you pick on other curves, you get back to a reasonable adjustment point. Now, at this point, we're essentially done with our sketch elements, but there's at some points in times you may want to actually constrain your geometry so that it moves a certain way when you adjust it. Okay. In this case, maybe we want to add some constraints to maintain the physical relationship that we have here. We can use that using our Smart Dimension capability. And there's a key thing, you can actually pick on endpoints, or you can actually pick on curves to create your constraints. And there's different behaviors to both of those. Notice if I pick a line, and I come down and adjust this line, I actually pick the top line into our x-axis, we're actually defining that this is actually a well-defined constraint. Notice our curve element changed to be green, saying that this is actually well-defined in one of the degrees of freedom. So we can easily set that by using the actual line. If you use the endpoint, you're actually not defining the line itself, you're only defining the endpoint. So then you would have to add additional constraints like the perpendicular or the horizontal constraints to actually constrain the line from changing its angle. Because the endpoint has a degree of freedom that this line can actually change its to an angle, not 90 degrees if you will. So let's go ahead and continue to place some constraints around here. For example, we'll go from our element to our outside that we had set earlier. We can do the same thing with our curves. If we want to set our height, we can set our height by selecting our top point. We can select our other line. And notice even if you pick on a 0 location, you can actually constrain that line element to the grid, and you can get that constraint inside of there. We can actually constrain this element to have a set distance inside of there. At any point, you can double-click these and change the lines. For example, we want to set it to be 1. We can change that distance using these constraints as well. The nice things about these constraints is they're always visible, so you can edit them at any time. Other things that we can add, let's add another constraint. Notice if we pick our angled line, we get the distance here, or if we pick another line or the horizontal line, notice it'll actually automatically change into our 45-degree angle inside of there. We also might want to specify this height that we had set before, and you can see that our elements are quickly becoming constrained inside of here. We also want to set the length of our geometry here to be 1.5. Actually, let's just do it this way. Let's constrain this curve to our other constrained curve, and we can see that as 1.5. So at this point, we're almost fully defined here. The only one constraint that we're missing is the constraint of our angle. In this case, we actually want to make this a parallel constraint, and we can just pick our parallel constraint, pick our green element, and our other green element to make those parallel inside of there. So now we actually have a parallel constraint, but we still have one missing constraint inside of here. So the last constraint we need to actually add is our thickness between these two lines to really fully define that. Because if you notice, without adding that, we can actually drive the width of this line still. It's still freedom to move inside of there. So let's just undo that move, put our constraint between this line. And again, notice that we pick the line, pick an opposite line, it will actually give us that constraint. And now we're fully defined inside of here. In this case, we now have a well-defined sketch inside of here. Another thing that you can actually take advantage of if you're used to constraints is actually you can turn some constraints on by default. So let me just zoom down just to show you what I mean. If we go to our right-click menu and go to Constraint, you'll see some options for automatic constraint geometry. And we also see an automatic smart constraint. This automatic smart constraints is really for elements like rectangles, parallelograms, and such. That's what this option is on. If you turn that one on, you'll see those constraints automatically turn on. But user can actually select specific ones that they want to use. For example, maybe perpendicular, horizontal, parallel constraints. And we'll go ahead and turn those three on. And let's just draw that same shape that we started off with before. Notice as we draw these lines, you'll see constraints automatically turning red as we draw those inside of here. And notice if we go parallel, notice all these parallel constraints automatically turned on, and our horizontal and verticals automatically turned on. And it's actually smart enough not to over-define your geometry. Notice both the perpendicular and the horizontals did not turn on. One or the other will turn on by default depending on your geometry. So you can actually, by default, automatically constrain your geometry to give some intelligence on how your curves will move based on how you created it. This is basically a user preference, whether you want these elements to automatically create or not. Some users don't prefer these because they really want the freedom to just, very quickly and easily, change the angles of these geometries and really muck up or modify your geometry to at will. And the constraints kind of hinder that process a little bit if you do use that. And so just be aware when you use those constraints, but they are useful in some operations. Some of the things with these constraints to note, these can be used also in parametric relationships. If you right-click here or at the scene level, you'll have parameters that define all your sketch elements. If you come out here, you'll see these are defining P1, PD1, which dimensions out here is PD1. These are the constraints elements. You can rename these parameters, tie expressions between those. For example, maybe you want the height and the length to be an equation between each other. You can actually put expressions in here, say PD2 is PD1 divided by 2, half the distance or something like that. Those are very usable expressions to help define or control your geometry for whatever particular use the user is trying to drive. In our case, we don't need to do that, but if we do want to adjust some elements, it's easy to come into our sketch. Maybe we want to make this 6. We can drive our element and get our geometry. And at this point, we can go ahead and just finish our sketch. And one other last note, I guess, once you have the sketch element, it is maintained into your curves on the sketch level or in the teleshape level. Notice if we come in here, all these elements are constrained. I can't simply just drag and modify this geometry. Same as if I selected this element, tell it to go ahead and create. Let's just create a spin from this. Let's open this up so we can see what we're doing here. So notice even if I try to drag these elements, all those constraints still apply. I can't just simply adjust this at will. If you go back into your sketch, we can say, for example, we just unlock one of these constraints. Now notice this one becomes ungreen. It's actually white again. If we go back and finish our sketch, now this handle is able to be adjusted. So if we wanted to allow the user to dynamically adjust the elements, you can create the unlocked sketch information inside of here. And they can actually use any number of tools. For example, maybe you want to set the distance of this guy from the center, back to 1.5. They can adjust that using the handles as well. So it really depends on the user's preference whether they want to actually add those constraints and allow modification with handles in the basically in context design, or if they really want it to be parametrically set and defined and not allow the users to adjust it freely in that regard. That's just from the sketch level. As in addition to the sketch, you can always use direct face modeling to modify the geometry at will as well. That would, again, remove all your constraints. But that's a user's preference, but something I wanted to cover for some of the newer partners. Hopefully this is a very useful tutorial basically to show some of the advanced capabilities of IronCAD's positioning capabilities, and they're quite useful once you get the hang of them. And there's all kinds of little other tricks inside of here when you're using some of these elements. For example, let's just take one of these off here and take a few of these off. When you're on some of these elements, when you right click on them and you hit edit, you notice there's options here for maintaining end conditions. As you notice, when I spoke earlier, when you edit some of this geometry, it maintained the perpendicular angles and such. You can uncheck these options when you bring up the dialog boxes to give that same behavior of holding the shift key down when you drag, where the lines can adjust freely depending on what they want. And that's useful for conditions like this. You know, if you wanted to adjust this length and maintain this angle, you know, that's what this option is on, and that's why it's on by default. If you uncheck that, this line could change, and this angle could change as well to solve or satisfy the distance that you set inside of there. That applies to both the end positions and actually the curve dimensions. Both have that same capability when you select on this and look at their properties. They both have this option inside of there. So that's something key to note, that you can access that inside these dialog boxes, or otherwise the user has to know that they're at the shift level to disable those options on and off. Hopefully this is helpful, and if you have any questions, feel free to ask.